Interactive computation of esProc. Compared with the development environments of other programming languages, esProc has stronger interactive capabilities, making it easy to conduct exploratory analysis. Start esProc and create a new script cell set. This area is where you edit the code, and the calculation result of the cell will be displayed on the right accordingly. Clicking on a cell can display the calculation result of that cell. Now let's take an example to experience esProc's interactive computation. For example, there are two credit data tables, listing.csv and user_info.csv. The first table contains the due repayment information and actual repayment information, etc. of some orders in 2018, and the second one contains the basic information of users. Now we want to join the fields of the two tables into one table for further data analysis. First, import the first table, and you will see the data directly on the right. By observation, it can be seen that this table has two ID fields, user ID and listing ID, as well as other fields, including the auditing date, due amount, repayment date, and repayment amount. Among them, the records with the value N in the repayment date and repayment amount fields indicate that the repayment is not made on time. Now, check the uniqueness of the two ID fields, enter the code in A2, A3 and A4 and run them, then click on the corresponding cell to view results. The results show that the values of the listing ID field are unique, while the user ID field has duplicate values, indicating that the same user may have multiple order data. Next, import the second table. To make the code look neater and more symmetrical, we import it in cell B1. Since column A has been executed, there is no need to execute it again. At this time, clicking on the calculator-like button above the cell set area can execute only the active cell. Alternatively, pressing Alt-Enter can achieve the same effect. After execution, the field information of the data can be seen on the right. Similarly, check the uniqueness of the ID field. This time we use the group function. Pressing Alt-Enter shortcut key to execute the active cell. It can be seen that the result is a two-layer sequence, with some sequences containing one record and others containing multiple records. Double-clicking on a member can enter the deeper layer. For example, double-clicking on the 8th member, you can see that the user with user ID 8 has two records with different insert dates. If you want to return to the upper layer, just click on the left arrow icon above the data. The ability to drill multi-layer data results is another feature of esProc, allowing us to understand some more complex data structures more intuitively. At this point, we have known that the same user may have multiple records, but it is still unclear which one should be taken. For the convenience of further viewing the differences, group them again by member length, modify the code in B2 and execute, which will return multiple layer data. Double-click to enter a user group with multiple records, and you can see that the age and location information of the users changes with different insert dates. The insert date can be understood as the update time of user information. That is to say, accurate user information needs to be selected based on the order time. After understanding the above information, let's associate the tables. Write the code in A5, and then perform association on user ID. From the result on the right, you can see that the records with the same user ID in the two tables are joined together. Then extract the required field information from A5. When writing code here, because it needs to copy the field name, it is usually more convenient to write by looking at the corresponding data. esProc also provides the function to pin the result of a certain cell. For example, clicking on cell A1 and then clicking on the icon at the top right corner of the data in A1 will change the icon's status to this. At this point, no matter which other cell you click on, the result panel will be pinned to the result of A1. If you want to unpin, just click on the icon again to return to its original state. After copying the fields of A1, it also needs to copy the field names of B1, select B1 and use the shortcut key F4 to switch the result to B1. Having written the code in A6, if you want to execute it separately and pin the result of A6, you can use the shortcut key Shift-Enter. After execution, you will see that the result panel displays the result of A6, and it is in a pinned state. From the previous analysis, we know that for the same order in the association result, there may be multiple user data. Now we want to select the correct data by the order date and the user data update date. To do this, two conditions should be met. One is that the order date must be later than the user data update date, that is, the historical order cannot be associated with future data that has not occurred yet. The other is that the latest data, i.e., the data closest to the order date, should be selected from the historical update data. After executing the code, A8 is the final result. Save it as a CSV file. Let's continue with this example. Now we want to use the join data to analyze the impact of user gender and age on loan willingness and default risk. Enter the gender and age conditions into A2 and B2 respectively, and write the final calculation result to A7. For example, A7-1 represents the proportion of male users over 25 years old in all orders. The higher the proportion, the greater the willingness to borrow. A7-2 represents the default proportion of male users over 25 years old. The higher the proportion, the higher the default risk. A7-3 represents the total default proportion. By pinning the result of A7, continuously adjusting the conditions in cells A2 and B2, and pressing Ctrl plus F9 to execute the code, you can easily view the impact of different genders and ages on the result. For example, by continuously changing the conditions, it can be easily analyzed that male users have a higher willingness to borrow than female users, and that male users between the ages of 28 and 30 have a higher default risk. In addition, esProc provides complete debugging functions, such as set breakpoint, run to cursor and step over. Let's continue with this example. To make analysis more convenient, we calculate the loan willingness and default risks of users of different genders at different age brackets. For example, we group users into 5-year age brackets, then calculate loan amounts and default ratios separately for male and female users in each bracket. Here we need to use a 2-layer nested loop, with gender as the outer loop and age bracket as the inner loop. When there is a loop statement in the code that needs to be debugged, we can use the step over function to enter the loop body for debugging. The calculation results of each step in the debugging process can be viewed in real time on the right. After the code is executed successfully, the table in A6 will be obtained. From the results in the table, it can be seen that the majority of customers are middle-aged people, who are the key targets of credit business, while the number of older people over 50 years old and young people under 20 years old is very small. Sometimes, in order to better analyze key targets, some minority phenomena can be excluded as outliers to reduce data noise. For example, according to the standard deviation rule, the data whose age is more than 3 times the standard deviation can be removed as outliers. Outlier analysis is a general method, and we can save it as a script and use it directly as needed. We still take the listing_user table as example to illustrate outlier elimination using the 3 sigma rule. The process is straightforward. Call the written script using the call function, and then select data within 3 standard deviations. For such code containing subroutines, we can use the step into function to enter the subroutine for debugging. The step return function allows us to return to the main program to resume execution. For the calculated table, we can also view the trend graphs. For example, we can view the default risk trends of male and female users at different ages. Structured data calculation is data-centric, involving data exploration and analysis throughout the process. esProc, a highly interactive tool, makes this process convenient and user-friendly.